Hi students, and welcome to your first video out of 5 short videos for today's lecture on Lewis structures. In this video, we're going to go over how to calculate steric number. So why is steric number, or SN, important to us? So it's important because the steric number tells us the molecular shape, which is why one of the first steps when you're asked to draw any Lewis structure will be to calculate the steric number. So how do you calculate steric number? The formula is steric number equals the number of valence electrons from the central atom plus the number of contributing electrons from the peripheral atoms minus the charge over 2. So the first thing that we need to do is we need to figure out what the central atom is and what the peripheral atoms are. So in order to do this, let's take the example of CO2 or carbon dioxide. So how do you tell what the central atom is and what the peripheral atoms are? So the central atom is the most electropositive atom. And here we have two choices, carbon or oxygen. Carbon is more electropositive, so carbon will be the central atom. And therefore, the two oxygens will be the two peripheral atoms. Now, the next thing that we need to know is, okay, we found out our central atom. We can know the number of valence electrons. However, what do the contributing electrons mean? In order to understand this, you can look at this handy-dandy table we have in the bottom left corner. And this shows you what the contributing electrons are for different groups in the periodic table. So hydrogen donates 1 electron, so you would add 1 for every hydrogen. Nitrogen and phosphorus in group 15 remove 1 electron, so you would subtract 1. Group 16 donates 0, so you just would add 0. And group 17 donates 1 electron, so you would add 1 for all of those atoms in group 17. So now let's use this information to calculate the steric number of CO2. So the first part is the number of valence electrons from the central atom. Carbon is our central atom, and it has 4 valence electrons, plus the number of contributing electrons from the peripheral atoms. So our peripheral atoms are oxygens, which are in group 16 and donate 0 electrons. So we're going to add 0. Our charge of this molecule is 0 as well, so we're going to subtract 0, divide this by 2, and we get a steric number of 2. Now, what does this mean? So I told you that steric number tells you the molecular shape of a molecule. So how can you translate between SN and the molecular shape? So here we have another one of the tables from your lecture notes, the steric number table, and this tells you how the steric number relates to the different structures. So the first thing to consider is that if you have a steric number of 2 and you have 2 peripheral atoms, this means that you're looking at the parent structure. That's perfect because the table on the left shows the parent structures for the different steric numbers. So what is the parent structure for SN of 2? Well, the parent structure is linear. So that tells us that the molecular shape of CO2 is linear. And we will continue with understanding the molecular shape of carbon dioxide in a future video.